This lesson is about circle theorems. So you are responsible for 8 rules or 8 circle theorems as shown in this figure. So let's start with the first circle theorem. So the first theorem states that the angle at the center of a circle is twice the angle at the circumference. So the angle at the circumference is A, and the angle at the center of the circle is 2 times A. So the angle at the center is 2 times the angle above it, which is at the circumference. So if A is 30, then the angle at the center is 2 times 30, which is 60. The second theorem states that the angles in the same segment are equal. So let's look at this circle. So if I look at this arc, so this arc and the second arc have the same segment. The first arc starts at this point and ends at this point. And the second arc as well starts at the same starting point and ends at the same ending point. So they both have the same segment. Now when the 2 arcs have the same segment, then I can say that the angles at the circumference are equal. So if this is 30, then this is 32. The third rule is the angle in a semicircle is 90 degrees. So if I draw a line that passes through the center, and this line goes from one end to the other end of the circle. So this line is called a diameter because it goes from one end to another end and it passes through the center. Now if I extend or draw 2 lines from this point forward and from this point until I meet this line, these 2 lines, they meet at 90 degrees. That's why the angle in a semicircle is 90 degrees. So you need to have a diameter, and when the 2 lines meet, the angle is 90 degrees. The fourth rule is opposite angles in a cyclic quadrilateral add up to 180 degrees. Now, a cyclic quadrilateral is a quadrilateral that is inscribed in a circle, and each corner point of the quadrilateral touches the circle. So if the 4 points touch the circle, then the quadrilateral is called a cyclic quadrilateral. So this is a cyclic quadrilateral. Why? Because this point and this point and this point as well, and the 4th point, which is this point, all the corner points touch the circle. Therefore, it is a cyclic quadrilateral. Now, if you have a cyclic quadrilateral, opposite angles add up to 180 degrees. So A plus B is equal to 180, C plus D is equal to 180 degrees. Now the 4th or the 5th rule is the perpendicular from the center to the chord bisects the chord. So this is the center of the circle and this is a chord. A chord is a line that goes from one end of the circle to the other end of the circle without passing through the center. So this is a chord, and this is a line that goes or that starts from the center till it meets the chord. Now this line makes a 90 angle degree or a 90 degree angle with the chord. Now when we have such a case, the line that goes from the center to the chord bisects the chord into 2 equal parts. So this line is equal to this line. So if this is 5, then this is 5. the angle between a tangent and a radius is 90 degrees. So a tangent is a line that touches the circle without intersecting it. So this is a line that touches the circle, so it is called a tangent line. And this is a line that starts or that goes from the center till it meets the tangent. Now, whenever we have such a case, the line that goes from the center makes a 90-degree angle with the tangent. The seventh theorem is tangents from a point outside a circle are equal in length. So I have a circle and this is an exterior point. Now if I draw two tangents, so the first tangent is this one and the second tangent is this line. These two tangents are equal. The last one is called the alternate segment theorem, which is basically if you have a triangle inside a circle, this angle here, which is A, is equal to this angle, and this angle here, which is B, is equal to the angle B inside the triangle. Now let's have an example to illustrate these theorems. So in this example, it says find the angles marked with letters. So I have A, B, D, and C. So I have four angles and we need to find the value of these angles. Now, according to the last theorem that we just explained, which is the alternate segment theorem, now the angle A is equal to 65 according to theorem number 7 or theorem number 8, which is the alternate segment theorem. So if this is 65, then the angle here inside the triangle is 65. So A is equal to 65 degrees. Now, how can we find B? Now, we know that the sum of all the angles of a triangle add up to 180 degrees. So 45 plus A, which is 65, plus B is equal to 180. So 45 and 65 is equal to 110, plus B is equal to 180, so B is equal to 180 minus 10, or minus 110, and the angle is 70 degrees. Now, since this quadrilateral is a cyclic quadrilateral. Why? Because all the corner points touch the circumference of the circle. So opposite angles in a cyclic quadrilateral add up to 180 degrees. So 45, its opposite angle is D. So D plus 45 is equal to 180. So D is 180 minus 45. And the answer is 135 degrees. So we found A, we found D, and we found B. So this is B, this is A, and this is D. Now, what's left is angle C. Now, this is an exterior point, and this line is a tangent. This line is a tangent too. So according to theorem number 7, these two tangents are equal. So this is a triangle. Let me point it out. So this is a triangle, and this side is equal to this side. So this triangle is called an isosceles triangle because this side is equal to this side. So adjacent angles are equal too. So if this is 65, then the angle here is equal to 65. So this is 65. Now how can I find C? So 65 plus 65 plus C is equal to 180 degrees. So 65 plus 65 is 130. So 130 plus C is 180. So C is equal to 180 minus 30, which is 50 degrees. So A is equal to 65, B is equal to 70 degrees, C is equal to 50 degrees, and finally D is equal to 135 degrees.